For years, we used AI as a sounding board. We asked a question, it gave an answer. But the technology has moved past conversation into the era of agentic AI, systems designed to autonomously execute tasks on a user's behalf. This shift is personified by OpenClaw, an AI agent that operates through its own dedicated marketplace, known as ClawHub. On ClawHub, users expand their AI's capabilities by downloading third-party skills. These skills aren't complex software programs. They are markdown-driven text packages that tell the AI how to behave. To be effective, these agents require deep system integration. They operate with permission to browse local directories, read system files, and use a user's active, authenticated sessions to interact with other platforms. Granting an AI the authority to act for us has moved the security focus away from protecting data. The primary risk is now the management of autonomous authority. Traditional software supply chain attacks are built on complexity. They rely on compromising code dependencies or hiding malicious logic inside binary executables. OpenClaw operates on a different logic. It functions entirely through natural language interpretation, reading and executing instructions written in plain English. This creates a massive opening for attackers. They don't need to write sophisticated software exploits to breach a system. They only need to provide deceptive instructions that the AI is trained to follow. Since the AI already holds broad permissions on the host machine, tricking its reading comprehension leads to a total system compromise without the need for traditional malware. Security researchers call this tactic semantic instruction hijacking. By writing malicious commands in natural language, threat actors force the AI to execute tasks using the user's own trusted identity. We can see this play out in a real campaign on ClawHub. In May 2026, an attacker uploaded a skill posing as a helpful assistant for TradingView users. To slip past scanners like VirusTotal, the attacker used file padding, placing a small malicious payload above 22 megabytes of invisible junk characters. Most automated scanners have a maximum file size limit. Seeing a document this large, they skip the analysis entirely. Through simple inflation, the malicious skill bypasses the marketplace's defenses and remains available for download in a trusted ecosystem. Once the skill is installed, the kill chain moves to the next phase. The skill uses a prerequisite block, an instruction that stops the AI from working until a specific setup task is completed. This block directs the agent to a paste site lure, bypassing the firewall to fetch setup instructions. This data is actually a scrambled base64 encoded command. Once decoded, it forces the AI's shell to connect to an attacker-controlled server, downloading a malicious info stealer like ClawHavoc. A simple markdown file has effectively weaponized the AI, turning an assistant into a backdoor for data exfiltration. While data theft is the most common goal, some attackers are exploiting AI autonomy to commit direct financial fraud. This is agentic front-running. This diagram tracks how compromised AI networks autonomously pool cryptocurrency into a single wallet. The attacker uses this coordinated activity to buy into meme tokens at low prices, creating artificial demand that they can later exploit. The agentic model allows threat actors to orchestrate pump and dump schemes with a speed and coordination that would be impossible with traditional software. The vulnerability here is fundamental to how these systems work. AI agents cannot distinguish a helpful prompt from a malicious exploit when both are written in standard text. Because of this, traditional antivirus and endpoint security tools are effectively blind. They are built to detect malicious code, not the text-based instructions that drive an AI-native attack. Defending these systems requires a more manual approach. Security teams must verify the reputation of every skill publisher and perform line-by-line audits of the source files. Monitoring outbound network traffic is equally critical. This allows organizations to catch agents if they attempt to communicate with undocumented or suspicious external servers. In this new environment, the software supply chain has evolved. Protecting our systems now requires us to verify the instructions of our automated proxies as strictly as we verify the code they run.